Hi, I'm going to be going over the configuration of a DHCP server on a Cisco router. I'm also then after that going to demonstrate a couple of things when it comes to DHCP conflicts. So my current setup is I've got these three computers down here. They're all connected to a singular switch with an IP address of 10.0.0.5. And that in turn is connected to router 1 here, which is going to act as the DHCP server. That's got an IP address of 10.0.0.1. So PCs 1, 2, and 3, they currently don't have an IP address. As you can see here, there's PC 1, 2, and 3. And going over to switch 1, which is probably the only time I'll be over here, just showing you that all ports are in VLAN 1, which is the only VLAN on the switch, so they're all in the same broadcast domain. So over on router 1, let's go and configure the DHCP server. So the first thing you obviously have to do is put in the excluded addresses. The reason being is that once you've configured the DHCP server, or configured the pool, I should say, then the router is going to immediately start responding to any DHCP requests coming in. So if you have any IP addresses that you don't want dished out within that range, you've got to exclude those first. So I'll just put in the range of 10.0.0.1 up to ending in .9, and so the first address that should be given out in the pool is 10.0.0.10. So now I can create my pool. Let's just call it LAN 1. And you need a certain amount and certain parameters within a DHCP pool for it to actually work. So obviously the first one is what's the address scope that you're going to use. That's going to be 10.0.0.0, and I'm going to use a /24 subnet mask. Now you also need to put in a default router. So that's going to be the router I'm currently on, 10.0.0.1. Now the computers need a DNS server. Now even though I don't have one on this network, I will just put in Google's just for completion, and it's optional, but I always put one in, and that is a lease. And just out of habit, I put it in as 8 hours. And that's your DHCP server. That will now start responding to any requests that come in. So I'll just copy that startup config and move over to PC1. So PC1, I'm going to statically configure with an IP address of 10.0.0.10. Again, that's the first IP address that is in the DHCP pool. It's going to have a subnet mask of /24 and a default gateway of the router. Voila. So there we go, that's now configured. So what I will do is I will actually do a capture of both of these links so we can see what goes on during the DHCP request. So that's the link for PC1. Here is the link for PC2. Okay. So over on PC2, I can issue the request for a DHCP address. And we can see the traffic going through. It does its DORA. And there's its IP address of 10.0.0.11. So let me just stop them and we can see what's happened. Firstly, let's go over to router 1. we can see that router 1 discovered a conflict. You can see that in the DHCP conflict table. So it tried number 10, or ending in .10, found that there was already a device on the network that had that address, and it discovered that via a ping. So let's have a look at how that happened. PC2, so this is PC2, issued its DHCP discover request, and router 1 first sent out an ARP request to see whether this 10.0.0.10 address is already in use on the network. So that was sent out, and obviously being a broadcast, that meant that PC1 received it as it's all the same VLAN in this network. PC1 replies to the ARP request stating that he has the IP address ending in .10, and router 1 does a ping request to that IP address to see whether it's actually in use and still on the network. During which time PC2 got a little bit impatient and sent out another DHC discover message. So at this point, the router knows that the IP address of 10.0.0.10 is in use, and so it sent out another ARP request to see whether someone had IP address of ending in .11. So that didn't get a reply, as we know that the only two computers on the network have the IP addresses of 10 and now 11. So that didn't get a reply, and so it offered that IP address, which was then requested and then acknowledged by PC2. Now, something quite interesting can happen with DHCP on Cisco networks, and that is what happens if router 1 loses power for some reason. Maybe there's a power cut, or maybe an administrator issued a reload command and then accidentally confirmed it. What would happen, given that both the DHCP conflict table and the DHCP binding table, which shows the issued IP addresses, considering that they are both held in RAM, what would happen? Now, when a router or any computer device reboots, the contents of RAM is lost. So let's try that. Let's reboot router 1. Now I'll pause the video here, as it can take a couple of minutes to reboot. Okay, so we're back, and what I'll first do is I'll just show you that the DHCP binding and conflict tables are now empty. So there's binding, and the show IP DHCP conflict table is also empty. So this router basically thinks it hasn't issued any IP addresses and there are no conflicts. So let's see what would happen given that we know that PC1 still has IP address ending in .10 and PC2 still has IP address ending in .11 due to it having an 8-hour lease. What would happen if we have PC3 request an IP address via DHCP as well? Let's find out. I'll start a capture. I'll move over to PC3 and make a DHCP request. Now, the first time that this happens, it often fails. I think it's mainly due to me using GNS3 and also the fact that the router is discovering that there are going to be two IP address conflicts, and that has to take into account the extra time for the ARPs that the router will do. So if I issue it a second time, it already knows about the conflicts and issues the IP address ending in .12. So let me stop that and go up to the top here. So this was the first time I issued the request. So there's the first discover. It asks about number 10, an IP address ending in .10 because it's no longer in the IP address conflict table. It does another discover, it does another ARP to see whether 11's in use because it's discovered that 10 is in use. Well, it's now discovered that number 11 is also in use, and so at this point, PC3 is issuing a third discover request, and so it's going to time out at this point, and so it actually the router does actually send out an offer, but it's got to the timeout period of the computer, and so it doesn't take it any further. Go further down, and here is the second request. Now, obviously, at this point, it already knows about the IP address conflicts of the IP addresses of 10.10 and .11, and so it can just go straight to doing a straight DORA request process, which gives the IP address again of 10.0.0.12 to PC3. Going back to router 1, I can issue the show IP DHCP conflict command again, and that will successfully show that it discovered IP addresses ending in 10 and 11 on the network and issued a IP address ending in .12. And so I hope that's helped people with kind of some basic questions with DHCP on a Cisco network.